This pH buffering test protocol is used to determine how well buffered a growing medium is to the addition of a mineral HCl acid drench. The goal of this technique is to measure how well buffered a growing medium is, and in the technique the overall principle is to apply HCl at 40 milliequivalents of acid per liter of substrate, wait 7 days, and measure the pH drop. The buffering capacity of a growing medium refers to its ability to maintain a stable pH following the addition of an acid or a base. Our research work with soilless growing media shows that the amount of residual lime in the growing medium is the main factor that affects pH buffering. This technique then takes one dose of 40 milliequivalents of HCl per liter of substrate and measures the pH drop, and we then compare that pH drop against a survey of commercial growing media. Here's an example of one of our trials. S1 through S11 represent different growing media. The yellow bars are the original pH, and the blue bars are the pH after we've added 40 milliequivalents of HCl and waited for 7 days. As you move from left to right on this graph, you can see some numbers after the letter R. Those numbers refer to the amount of residual limestone or calcium carbonate equivalents in units of grams per liter. So on the left hand side of the graph we tend to see growing media with little residual lime. On the right hand side of the graph, growing media with larger amounts of residual lime. And also as we move from left to right, we see that overall there is less and less effect of the HCl drench in terms of dropping pH. And this graph summarizes that result. Different amounts of residual calcium carbonate equivalents were measured with the gasometric technique. On the y-axis it shows the delta pH or pH drop. And so clearly you can see that increasing the amount of residual calcium carbonate equivalents reduced the amount of pH drop and therefore increased the buffering to pH change. Now this is a lab technique without any plants, and if we compare those lab results with the drop in pH when we grow impatiens in a greenhouse with a 100% ammonium fertilizer, so a very acidic reaction fertilizer, we see that the drop in pH from the HCl drench is very closely correlated with the drop in pH when we grow a crop of plants. In other words, the pH buffering that we're measuring in the lab is very similar to the behavior that we would see if we grew a crop of plants in the greenhouse. There's another concept that we use in terms of buffering using the HCl method, and that is this pH 4.5 buffering capacity. That refers to how much hydrochloric acid is needed to drop pH in that substrate to around 4.5. We don't emphasize that technique in our protocol, but in our research work we've added different milliequivalents of HCl per liter of substrate to get a titration curve. And what this graph shows is along the x-axis is the initial residual calcium carbonate equivalents measured with the gasometric method, and on the y-axis it shows this pH 4.5 buffering capacity, how much HCl was required to drop pH down to 4.5. As you can see, the two methods are very closely correlated. Now here's our interpretation table. It's based on the work we've done with commercial and research growing media. If you run through this method and you measure the pH drop or delta pH after you add 40 milliequivalents of HCl, you can compare it with this table to get an idea of how well buffered that growing medium is. So, for example, if the pH drops around 1.5 units, we'd call that a medium buffered pH. From our experience, that means that there's probably around 1 to 3 grams per liter of residual limestone. And just recall that 0.6 grams per liter is the same as 0.6 kilograms per cubic meter, or 1 pound per cubic yard. So just briefly going through our procedures, you will need to make up a solution of 0.5 normal HCl. So here on the graph it shows some examples of how to make up that standard solution. With your growing medium, you need to measure out samples of 200 milliliters and put them into a series of open plastic bags. So we'd recommend that you do 2 sets of 3 bags. One set is going to be used for a water addition, the other for an acid addition. So for the first set of 3 bags, add enough distilled water to raise the moisture level to approximately 95% container capacity. The growing medium should be completely saturated, but not with much free water in the solution unless you squeeze it. For the second set of bags, you're going to add 40 milliequivalents of HCl per liter of substrate. And so here there's some details about the steps that you would go through for adding the HCl. Leave the plastic bag at room temperature around 20 degrees Celsius for gas exchange. If you want to speed up the reaction, then it's possible to maintain those bags at a warmer temperature. After 7 days, you're going to measure the substrate pH. Calculate the difference in pH between the acid-treated growing media and the water-treated growing media. That difference is the delta pH. Use the tables based on our survey to interpret how well buffered the growing medium is. We'd like to thank the staff and students at the University of Florida who have worked on this project, Bill Argo from Blackmore Company, Paul Nelson and his team at North Carolina State University, and also the funding for this project from American Floral Endowment and the Young Plant Research Center. The Young Plant Research Center is a group of universities and industry partners that includes leading growing media and fertilizer companies, and also some of the top growers who are propagating plant material.